Hello, my name's Richard Powell. I've been programming in C++ for, well, professionally 20 years. I've had the opportunity to work at a variety of companies. I started off at Beatnik. I couldn't find a better logo than this pixelated one. I did audio software at Beatnik. I did audio software at Apple for a long time, and then I'm currently at Meta doing audio software. So I work in audio software. It's a fun domain to be in. It favors performance. It favors creativity. A lot of times it favors digital signal processing. I find it fun and fascinating. But I really do love programming a lot. So I'm less about the DSP and more about the programming. Let me tell you about my this talk. There are so many amazing talks online about declarative programming. There's these examples of them, but when I see the end product of a great declarative programming, maybe from Ben here, it tends to feel to me a bit out of reach. Like when I look at the code I'm working on, I'm dropping into a code base that is a jumble of things, and I don't really see how those lessons could apply to me. But I started working on a side project, and I found that I could incorporate a lot of those ideas of declarative programming into the work I was doing, and I wanted to take and share that, the process, as a way to make it possible for you to see what you can do with your code. So really this talk today is going to be a case study. I'm going to start off with here's where I started off, and this is where I ended up, applying some techniques along the way that I would say help you create more declarative programming data, more declarative programs. So these will be practical techniques that you can use. Even if you don't use all of them, you can probably start incorporating these in code today that you're generating. And my case study is going to be on UI framework. It's going to be, we're going to be walking through GUIs, but this is not a talk on UI frameworks. This is more of a talk, I'm using this as an example. So you may not quite understand all of the framework I'm using, but hopefully you'll understand enough to see the techniques I'm using. And so let's start, let me sort of say what my journey was to programming and how I got here. So I'm a proud member of the California Marching Band. It's a unique organization. A lot of big schools have their marching band programs and their football programs, but the Cal Band is unique in the fact that it's mostly student run. The director is a college student, and they chart they write the music for the shows. The students write the music, they'll arrange the music from songs. The drum major, he's a senior, or he or she is a senior and leads the band. They do all of the rehearsals. They organize all of the money, funding, trips. They're all sort of student run. And it was a great experience I had during college. I was there all 4 years. I often tell people I majored in electrical engineering and computer science, but I minored in band.
What did you play? You play instrument?
Yeah, I play trombone.
Oh, okay.
So, in fact, actually, I don't think I'm in this picture. Yeah, the trombones they keep them in the back so they're out of the way.
They're just very loud.
Extremely. And so one of the unique things the band has is CalChart, which was a computer program started back in the 90s. So when the band wants to chart a show, what they have to do is they have to tell everyone where they're going to be, and then they have to chart the next place where they want people to be, and then they'll have animations. They have to tell people where to march to. And they used to do it with pegboards. And back in the early 90s, they sort of developed a way of doing this with a computer program. And in fact, there's an DSL, a sort of a specific language that describes where people will march to. And it's its own sort of like tiny programming language that exists inside of this larger application. And for my senior year, I worked on this particular part of it. I took a computer graphics course. It was 1999. It was my introduction to C++. I have no idea what version it was, but it was probably right about 98, maybe pre that sort of 98. Both me and my partner, Andrew Way, were in the band, and we wanted to create this OmniView sort of viewing program, sort of 3D view of what's happening on the field. And if you look closely, you'll see that every one of those marchers is a small picture of Andrew Way, my partner. So they're all there. And several years after I graduated, I stepped up to help maintain CalChart, and I've been working on it ever since. And if you want, there's a, it's all written in C++. It uses wxWidgets as a framework. If you want to, you can download it, give it a shot, try it out. It's actually it's a pretty extensive, large amount of code, but it's not an impossible amount of code for any one person to work on. And so it's written with wxWidgets. Now, there are several C++ frameworks that exist. I'm sure a lot more people are familiar with Qt. Another one's Juice. There's others. But my journey led me down this path to use wxWidgets. And that's what we're going to sort of use as our case study today. And I'm not a definitive expert on wxWidgets. Yes.
I saw Juice doesn't have any graphics, am I wrong?
It has some basics of UI sort of framework. So if you want to create dialog boxes, you want to create larger applications, you want to create plugins, and have things look right, it has plotting facilities for that. Okay. Yeah, Juice is very much an audio framework, which is why I'm familiar with it. But it does tend to have sort of a large library of facilities to make cross-platform constructs. So wxWidgets has all the framework, all the fundamentals you need for graphics, like menus, dialogues, more complicated ideas like document management, do-undo systems. You have different controllers for creating your UI elements. It reacts to events. You know, I can probably, let's actually just construct a little app to give you sort of a foundation. So when I do the code later, you can see how it works. So I will break out of here. Let's go over here.
I like to describe wxWidgets as like MFC without the horrible.
Yeah, maybe that's a good way to put it. Yeah, so let's quickly.
You'd be surprised.
So I've created, on that link, you'll find that there is a very simple project I set up. I've got my CMake and Hello World list. And so if you were to look at the, come on, make it bigger. CMake list is, what I'm doing is I'm just looking for wxWidgets, incorporating into a very simple Hello World project. And my Hello World project, very bare bones. This also is the way that wxWidgets works. I worked a while ago with a gentleman, Jeff Lee, who told me like the UI framework greatly influences the way you program your code. Your program is going to look like your UI framework. If you try to go against the UI framework, it's very difficult. So you kind of have to lean into the paradigm of the framework. So we're going to lean into it. I'm saying that in advance because there's a lot of undesirable techniques, I would say, in modern programming that you probably wouldn't use. There's a lot of naked news. There's a lot of implicit resource management. We're not going to tackle those today. Just sort of, I hope you can turn a blind eye so we can focus on other things. So the structure of wxWidgets is pretty straightforward. You inherit from the app. It signals that this is the app. And you create a frame, and that'll be the sort of element that you will draw or put your controllers upon. And this is a very simple one. I'm just going to create a basic window here. And if you run it, and everything's been working out fine. Yes, so it created a very simple frame. Nothing in it, no menu, no nothing, very bare bones. Well, let's populate this with a couple of things. So what I've done here is in my frame, I've created a couple member functions which do some particular functionality. The sort of concept that wxWidget has is events. You declare sort of events. You can create an event table. You can connect functions to events with this sort of macro table magic. And it just sort of allows the framework to connect the events and interactions to code. And so then I initialize it, show the frame. And in the frame is where I am going to construct my menu. So this should now have a menu bar. So let's take a look here. Create, boom, and now, oh yes, now I've got these nice menus here. It feels more incorporated into the OS, and so we can actually quit now. Okay, and now let's use the example 3. Now this is actually an example lifted straight from WX, like this is their sort of example page. So if you were to go through wxWidgets tutorial, you'd probably end up writing something like this. And so most of the structure above is the same, but in the frame, we've extended and added more controllers. And so the menuing system is all the same. But you'll note here is where we start creating the controllers. And the paradigm that they use is you create your controller passing in a parent to it, a parent window. That's going to manage lifetime. So it builds up a hierarchy of ownership. Yes, they just sort of create them on the heap. They sort of, the framework handles the memory management. So at the exit of the program, it will clean everything up. So it does feel a little scary, but it is the way that the framework has been structured. So you can see it looks like I'm creating some static text. There's a text controller, probably some sort of text box, some buttons. There's a bunch of stuff. Oh, it's a radio box button. So I have these sort of controllers. They're all sort of descriptive in their name, and we can kind of envision what this is going to look like. So I create all these controllers. Then we lay out the controllers. So this is a lot of UI frameworks have a separate file for layout for complicated UIs, maybe an XML file or some sort of description language that tells how to lay things out. There's a way to lay things out programmatically. And so what you would have is these concepts of sizers. Sizers have a dimension. You can add controllers into it, and the idea being as you dynamically resize, the sizers will inform how to put those controllers together. And so I can see I've got these controllers all laying it out. And the final step, we set the sizer on the main frame. There's an implicit this, so this is a frame member function. And we can connect functionality via lambdas. So if you have a button, so this would be my button, it has a specific lambda associated to it when this event is emitted. All right, so why don't we take a look at what this looks like? And it probably mirrors our expectation. Right, so I've got a couple of static texts here. These were those sort of static text controller, radio buttons, checkboxes, pull downs. It's all the things you would expect to find in sort of any framework. If I click on this button, hey, I got the press left, a log message that came up as an alert, right? And so, yeah, any sort of generally makes sense. Like you probably now you're all wxWidgets experts, right? Go. Cool. Let's go back to here. All right. All right, so let's pick apart again, just to reiterate what we looked at. So we have our controllers, like I said, and we'll note that as each one of them creates one of these other controllers, and they're pretty descriptive on what they are. A button is a button. A radio button is a radio button. A checkbox is a checkbox. Parameters can take additional, the controllers can take additional configurations via arguments. So as you create them, you're saying, hey, this is the name of it. This is the behavior it should have. And so that allows you to customize the way that controller behaves. Let's scroll down and take a look at the layout section. And so our layout section consists, as I was saying, of sizers. And so, what we have here is we'll have a vertical sizer, we have these vertical sizers where I add text to. And so you can kind of see, hey, I'm laying out these text controller. And then this next portion here be a horizontal slider where I'm laying out my checkbox less this. So it lays things out sort of in this sort of box pattern. And these box sizers have that sort of attribute of which direction to lay things out. And my buttons would be left and right. That's where they get laid out. And then I have a larger sizer, which is the top level sizer, which will lay out all of these elements together. Cool. So one of the things that I observe often is the layout is quite fragile. Like as I'm laying things out, there's a there's a big jumble of code here. It's really easy to miss something. There's repetitive names. It's just a spaghetti word salad here. So imagine if you accidentally forgot to lay out like a new sizer and you just didn't add that. What would happen is you would end up with a UI that looks like this. And because you sort of you've created those controllers, you've added them to the frame has no idea where to put them, so it's just going to all put them at the top. And so you end up like, oh, that doesn't look right. Another thing that often happens is you misuse a name, or somebody accidentally does a typo or a find replace, and you end up sort of with the wrong layout because I used the wrong word here, and now instead of laying things out this horizontal and vertical size, it just laid it out all vertically. The controllers are still all there. They're still functional. They just don't look right. And so this makes the layout of the code very brittle. And so this is where I had been dealing with our code base in wxWidgets for a while. And I was like, if I look at these two sections of code, it's striking how different the two parts are. I think the code on the left is easier to understand what's happening. I can see from the names, it's telling me what those controller objects will be. I can sort of see what is going to be the result. But on the left, but on the right-hand side, I'm kind of lost. I'm not sure. I have to there's a lot of mental energy trying to parse what's happening on the right side. So what is it about these two sides that, why is one easier to understand and comprehend? What I think it is I think it's telling me more on the right-hand side of what to do as opposed to how to do something. And the left-hand side is all about how to do, it's very much telling me what it's going to be on the right-hand side. But on the left-hand side, I can't really understand what it's trying to say. I think that I would say that the code on the right-hand side is more declarative than the code on the left-hand side. It feels like the other side is more imperative. Yeah, Dennis.
Maybe lost. Is it code on the left-hand side and the code on the right-hand side do the same thing because they look very different?
No. This is the part that creates my controllers, and the other part is one that lays it out. They're in the way a lot of people program in this framework. They keep them separate, and that can actually cause, as I say, all this confusion. You're like, I'm not even sure really what the code on the left-hand side is doing when I look at it. I mean, it's laying things out, but I'm not sure how.
I think you might have your lefts and rights mixed up, and maybe you should.
Oh, I'm sorry. I am standing here. Okay. Yes.
Stage left.
We'll fix this in post. Just substitute everything I said with left with right. So as I'm saying, the left-hand side, all right, I'm just going to move forward.
Maybe point.
I made my point enough, which is, I'd say that what we find was the left-hand side was probably more declarative than the right-hand side. It was very imperative on the right-hand side. It's telling me specifically the steps it wants to do, but not really what I want to have as the result. And I'll take another great talk that if I'm sure you've all watched is Ben's from 7 years ago talk. And I think one of the other ways I'd put it is there's a lot more statements on the right-hand side than there were on the left-hand side. There were more expressions on the left-hand side. And so I think there's a quote from that: declarative programming is the preference of expressions over statements. And I think that's what I found after going through all of this work. I'd also say there's this great talk that if you haven't watched, is also worth checking out, is Kelvin Henney's declarative thinking, declarative practice, with the statement of data structures. Data structures are programs. I think my talk, the rest of it is going to be about incorporating those ideas and refactoring our code to see the declarative program that exists within there. So to reiterate, the code on the left is more declarative than the code on the right. It's telling me more. I can tell just from the names what I'm probably going to get, but on the left, I'm not really sure. The one on the right-hand side is more imperative. It's walking through all of these statements of what we need to do. But the code on the left is more about these expressions that are declaring what we will have. So how could we make the code on the layout more declarative? All right, so I'm going to first make this a much more simple example so I can fit it all in one slide. This is a pretty, just really trimmed down UI. It creates a little dialog box that looks like this. So I have a frame, I've got a button that's a click button, a text controller that has dog in it that you can type into, some static text, and another button. And the button, the done button has a specific ID so that when I click it, it exits. And then I lay it out. As you can see, I'm laying out horizontally, and then sticking in a top-level vertical sizer. And then at the very end, I set it on my top-level sizer frame, and so it just all fits. So this is where I declare my controllers. This is where I lay them out. So let's do some refactoring. And because there's a data structure in here, it's a little hard to see, but let's refactor it and it should emerge. So first of all, I'm an almost always auto programmer, so we don't need to repeat the statements we're saying, so let's just reduce that. Cool, easier to see. And now it's actually probably pretty obvious for a lot of people that it seems unusual that we are declaring and creating our button and we're just immediately using it. Why not do those two steps in place? So let's merge those together, and we'll end up with a program that looks more like this. Okay, now we're starting to see, hey, there's a lot of repetition here, a lot of things that look similar. Let's go ahead and identify those. So we have common things that we're doing all over the place on specific types that could be different. And we have values. Our value parameters are all different. So whenever I see something like this for refactoring, I think about functions. And functions, when I want to pass in values, I take them as arguments. When I want to pass in type, I take them as templates. So let's create a function that would do those steps. So I'm going to put everything in a namespace. Let's make things clean. And we will have a function. I'm going to call this function createNadd because that's effectively what we're doing here. We're creating a button and we're adding it to a sizer. We're creating a text controller, we're adding it to a sizer. So we'll have a function that, given a top-level parent that's going to handle the ownership, given an ID, a string, a sizer, what it's going to do is construct whatever that W type is and add it to my sizer. And so as we said, like on the previous slide, we have our common things. So on those statements down there, I've added it there. I have my type parameter, so I can pass that in as a template parameter. And we have our values, which I'll pass in as arguments. And so should be easy enough to just do a simple refactoring. And so there we go. So now I have, there's still statements, but I've abstracted what it's doing behind a function. So I know I just added namespaces. I'm going to drop them because the screen's going to get, there's going to be a bit more code, and I don't want to reduce the font size. So what I have here is I have a type, and I have state. And so those arguments are my state. Instead of having it as a function, I want to create a data structure. So I'm going to modify this so that instead of having it be a function, I'm going to create a data structure that's going to hold on to that state. And then when I call a function on that data structure, it will call that function. So basically, I'm going to move this function into more of a data structure. So let's first create this struct that I'm going to use for holding on to my values, my arguments. And then what I'm going to do is, so you can construct it, and then it will have a createNadd function. And if I then refactor that, my code would now look like this. So it's effectively the same code. It's a little odd when you first see it. It's like, wait, you could have just called a function. Why are you creating a data structure? And then you're just calling a member function on that. That seems a convoluted way of doing argument passing. And I'll admit there's probably some efficiencies, and I didn't write this code to be as efficient as possible, so there may be some implicit copies going on. I understand that. But my point on this is I want to restructure the code so I can see the data structures that are inherent in what I'm doing. Cool. I also note, this is a little tiny detail here. It might not be obvious to see, but this particular controller has a different sizer in it. This is one of these little tiny UI details that you get into when you're designing UIs, is when you expand it, you want certain fields to get bigger and smaller. And that can be a detail that not a lot of people, like UI designers are very obsessed with this. Some people were like, whatever, they're controllers. And like, no, a lot of times people be like, I want the button to go this way along with when it gets larger. And so that little tiny detail can be important. But you'll note actually it's different from these others. And so it's making the code sort of less consistent. And it actually, to me, feels like, that particular characteristic of that text controller should be part of the data structure, not really part of the function. So what I'm going to do is I'm going to allow, if you have a specific thing to do for a sizer, take it as an argument for your constructor of that data structure, your widget data structure. So now what it is if we note my create and add functions, they all look homogeneous. They're all sort of the same. And I've made it so that I can allow selective complexity when I construct that widget data structure. Okay. We can start seeing there's a data structure emerging, but we still have a fair number of statements. So let's see what we can do to collapse this further. Let's make things a little easier to see. Let's just concentrate on this one section. So what we can see here is we have several different objects that we're all doing about the same thing on. I have a collection of types, but they're heterogeneous types. Well, what's a heterogeneous data collection? Yeah. Yes. Yeah.
Vector of unique pointers?
Vector of unique pointers? Yes, I guess so. But there's maybe another one. Tuple. Yeah, this is a tuple. It's just like right there in the code. And now I want to call, effectively, if you look at it, it's the same function on each element in the tuple. How do I call a function on each member of a tuple? Standard apply. I mean, there's probably more ways to do it than standard apply. I'm sure there's plenty that are emerging, but I would reach for standard apply. Standard apply, admittedly, I think the syntax is rather obscure. Like it's hard to, if someone told you to use this function, to figure out the right way to do it the first time. But standard apply is what we need to reach for. Okay. So let's collapse our multiple statements into a single data structure. So there we go. We got our one data structure, and now let's call standard apply on it. So yeah, now it's actually becoming more apparent. I have a data structure. I have an algorithm. I'm calling an algorithm on a data structure. I'm programming. So we have the flags that are in that sort of create and add functions. They feel very argumenty. So let's pull those out. Let's add those be captured by the Lambda. All right. Let's refactor this to a standalone function. So let's not have this in the code. We want to reuse it. So let's have a standalone create and add function, which will take any number, it'll take a tuple of widgets and we'll call apply, and it'll call the create and add on function on it. So essentially just goes whoop, whoop, whoop. And we refactor our code, and effectively we're doing that. I think there's a bit of a win we can do with a little helper function. It's saying that's a tuple isn't really necessary, so why don't we add a little helper function that makes the tuple for us, and there. Now I think it's I think this feels a lot, we're getting to a place where it's more declarative on what we're doing. And I'm sure there's ways for us to avoid some of these copies on the widgets. I probably, in more production code, you'd have the correct forwardings that would go on. But for slideware, please pretend. Let's make this easier to type. I don't really need to say that I'm having this widget. It's harder to reach for. Let's make something easier to reach for. Okay, now it's like, and these are more human readable words. Yes?
I maybe missed it, but do you understand correctly that in no way you specify at the moment where those things are, and that's the default thing?
What I'm doing is I'm using the sizer bottom to, I'm basically creating these controllers and I'm adding it to that sizer that's been passed in. So, so I'm saying where they are by the sort of sizer sort of layout. So the sizers, like when it comes to most UIs and widgets, wxWidgets in particular, you generally favor sizers to say where in a frame they're going to be. You can actually place them specifically, but generally use a sizer and you say this sizer is going to go up and down, this sizer is going to go left and right. And in this case, I'm saying, given this bottom sizer, which is a horizontal one, add these controllers to it.
So it's just add one after another at the bottom.
Yeah, they're very implied to be sort of, as you add them, is stack-like, and they will lay out this way or lay out this way. And sizers can contain other sizers, can contain other sizers. So you can have these complicated data sort of layouts.
Okay.
Yeah. There's a couple other types of sizers. They have like box sizers where you can graph things and do things, but the most common layouts are vertical and horizontal. And with those, you can generally compose most UIs. Cool. You know, we should be a little careful. Oh, wait, here we go. We should be a little bit careful. We're just taking any W here. Maybe we can use some sort of constraints. So we're only really allowing, we're only really calling create and add on it. So why don't we create a concept called create and addable? It just requires that the thing be support a function that's create and add. So in that case, the create and add function takes a tuple or a set of create and addable things. And the nice part about that is now I can add some static asserts to my code, and I'm starting to feel like developing a more cohesive framework here. All right. Let's zoom out and look at the larger code. Now, this is our example we were starting with. I have my sizers. I have my vertical sizer that lays them out, and I've got my two horizontal ones. It looks like, it feels to me there's a bit of a refactor opportunity we have again. We can see our common things that we're doing. We can see our, type parameters in red, value parameters in purple. So we can see that we've got like these sets of types that we're dealing with, and we have all of these parameters that are being passed in. So let's do what we did before. Let's look at a data structure. But one thing that is slightly different here is what we're doing here is these, there's two steps what we're doing. We're creating a sizer, and then we're adding things to it. Let's put those two statements into one sort of expression. So we'll do that by creating our data structure. And what it will have is it'll have a create and add function that will return a sizer. So instead of having it be create a new sizer and then add things to it, let's put those two things together. Create and add onto a high-level parent window, create all the controllers that we want, and then we will add it and we will return the sizer that we created. And so that allows us to write something more like this. So instead of having two statements, I just now have one declaration. Yeah. And so then I can, so if we look here, I see that we have these two statements again. We could probably put this secondary statement within the first one. We can, again, reduce our sort of number of statements by just have this create and add function do a little bit more work. So instead of returning the sizer that we immediately call add on it, let's just do that inside the body of the function. So now we have just one expression there. Sizer data structure gets created. We call create and add on it. And what it does is it will create an internal sizer, go through, stamp out each of the controllers it needs, adds them to it, and then adds itself, the thing it just created, to the parent sizer that was passed in. So now it's definitely more of an expression. The sizer flags here are a little redundant. I have two of them. Maybe we'll have a convention which is we will favor the one that's been passed in, the one that's in the argument. So let's sort of allows us to have a different orientation, something that doesn't take a sizer, and we'll just use the argument that's been passed in. So that allows us to get rid of that function. Cool. Now, the sizer is taking in this orientation, and that orientation is an enum of really just 2 values. And it really seems a little odd to take in an entire register just to express 2 values. It also feels like a place where someone can make a mistake. So why don't we create some specific classes that will just help us out with this? We'll call them hsizer and vsizer, and they'll be the ones that are for the vertical ones. Now it's really much more explicit about what I'm trying to do here. Easy enough to incorporate that into our code. So instead of having a sizer, we'll just call that an hsizer. Cool. Right. So, Ben.
Question, I don't know if you're going to suggest this, but would you consider moving the vertical horizontal argument into a template argument?
I had thought about that with some of the work I had done, but I found this a little easier for me to just code out. That's the way I thought. I hadn't done that, but I think it is possible to do, and that way it would be another way to do it. I just did it by hand like this. Yeah.
Wouldn't we want to move the construction of the sizer within the sizer class? Maybe?
Which one? Oh, you mean that sizer that's standing out by itself?
Yeah.
Well, there's an interesting thing actually. Yeah, I'm going to get to. Yeah, there is an interesting thing with my sizer. My sizer takes create nadables, but there is this interesting thing about sizer itself. It has a create nadable. Sizers are create nadables. So widgets are addables, but sizer itself are create nadables, which is this interesting thing, like this data structure that's emerged that like they're sort of a recursive data structure. Like sizers themselves could take in other sizers because they can take in things that are create nadable. And in fact, actually, so this allows me to make some static asserts, which would be that is a horizontal sizer that takes in a button and controller create nadable? Yes, it is. Well, is a vertical sizer that takes in 2 horizontal sizers create nadable? Yes, it is. So effectively, we have created sort of this tree structure. So let's exploit that. So given this, like, I think what you were saying is like, couldn't I take those 2 sizers and stick it into a top level vertical sizer? I believe I can. There is just sort of a bit of a problem with this, is that sort of top level sizer doesn't, like the top level one doesn't have a parent that it adds to. There's a specific set and add function. It doesn't look the same as everything else. The top level sizer is a bit unique. But I think we can figure out a way to deal with that. Why don't we skip that for a second, and we'll create a create an addable function that takes in a parent and a sizer to add to, and we'll create a version that doesn't take in a sizer. And so now what I should be able to do is write this, as you were saying. It's like, hey, I'll just have a vsizer that takes in horizontal sizers that will take in buttons and controllers. And then at the very end, set size and fit. We've got a little bit of redundancy here with that sort of, it's setting its particular sizer flags, but the top level is passing it in. Why don't we have our convention be, if something takes something by argument, it overrides what's in the base classes. That way, if lower classes want to do, if lower controllers and layouts want to do something specialized, they can add it. But it doesn't look like, in this code example, it's very opinionated, so let's just get rid of that. Cool. So can we reduce this into one expression? So to make it a little clearer about what it is that's that set sizer and fit looked like it was a free function, but it's not. It's part of the frame, so there's an implicit this there. Well, can we reduce these two statements into one expression? Yeah, let's just add another function to our data structure, to our sizer, called, can't think of a better name, how about fit2? And so now what we do is we can collapse this into one expression. All right, it's a good time to recap. This is where we started, and this is where we ended up. we did a bunch of refactoring here. We sort of, simplified, refactored, and when we were in the process of doing that, we saw there was some data structures in there, and they emerged really much more crystal clear after we did the refactoring. And and it's a nice, compact, single expression that really, just when I look at it, it looks like the code that it's going to produce, or looks like the UI is going to produce. Yes.
Do you think the code on the right is as powerful as the code on the left?
Yeah, I think it is. I think it, well, powerful is an interesting word. Is it as like efficient? I actually, like in terms of number of instructions?
No, in terms of what you can do.
I think for this simple example, it can do all that stuff on the right. But this is almost like a leading question. It's like, well, how flexible have I created this? Am I going to run into problems? How can I build on top of what I had? Well, actually, that's a good leading question. Let's see how flexible this solution is. So I'll note that for my example, I wasn't really using the full APIs that wxWidgets supports. They sort of, if you take a look at controller, for example, it takes in a lot more arguments. You can control that widget's controller's individual position within a framework. You can control its size. You can control its names. You can control its styles. Styles being like if I press it or I push a style in wxWidgets is if I have a controller and I push enter, it should emit an event. And so they communicate that with more styles. And right now, as things are written, I don't have an ability to do that. Now, what I could do is I could add more entries into the data structure, the widget data structure, to hold on to that. So that when I construct it, I would now have a lot more flexibility. But then how would do I just add them to the constructor, and now this constructor has many versions? And if what do you do if somebody wants to set position without setting size, or size without setting position in their default arguments, and you end up with a lot of constructions? That just doesn't scale too well. So for me, if I have a struct that has a bunch of values in it, I would just have a setter. You want to set a value? Just have a setter. So let's just do that. Let's just add a setter. I'm going to set one of those individual ones. We'll call it with flags. Because I have my text controllers doing something special for flags. So instead of constructing with it, how about if I don't know why that animated that way. Okay. Oh, oops, that was a typo. That should, well, the more important thing is the with flags there. So I have I'll take with flags. I'll just modify that data member. But when I do this, I get a big compiler error. Probably, if we go back one slide, anyone know what the problem is?
Yeah, you need to return this.
I need to return this. Yeah, exactly. So what it is the return type of void doesn't, like, H-sizers don't take void. They need to take a create an addable. So let's actually create an add and return this. Anybody know this pattern? Sure, we all do.
Builder.
Huh? What?
Builder.
Builder pattern. Other names for it? Anybody?
Oh, fluent stuff.
Fluent style. Yeah, fluent builder pattern. I've actually heard several of them.
Can I ask a question?
Oh, yeah.
Back. Here you're adding the new functions with flags. Have you considered to use like a structure as a constructor argument, like configuration, and then use designator initializer to say, okay, set flags and set these like.
Oh, so like having like a parallel data structure?
No, like right now, text control would accept like a structure, which was, you already know all the configuration options for the widget, right?
Oh, right.
And then you can use just another braces and then use designator as initializer and its relation.
Yeah. I could have had like another sort of configuration pack that comes along with it that contains all the things. You'll actually notice wxWidgets does something that with the sizer flags. Sizer flags are actually like 3 or 4 different elements of like which way to go right, left, horizontal. They have a lot of OR instructions. And you'll even note they are using a builder pattern in this example for constructing it. So yeah, I could make a larger one for making it one thing, or I could, I'll show in a second, another way to approach it. So, but Ben.
So I don't want to get in the weeds here, but text control here is an R value, and with flags is returning an L value where probably you should consider either overloading or R value reciprocal flag and returning R value. Something like that.
Yeah, and probably it would make, yes. I believe I do that in the larger library, or if I'm not, I'm there. Because yeah, for slideware, you're exactly right. And you can actually do specific things with ref qualifying. I'm really waiting for deducing this because I think it would make things a lot easier in the code base. So yes, absolutely. Be careful about how you qualify things so you make sure that you don't forward something that is out of scope. But the method, I've called this method chaining in the past, looks sort of like this, and it allows you to set several things in a very sort of, I would call it, it's idiomatic, but also very declarative way. I want a button. I want it red. I want it to be this large. I want when you mouse over it to bring up the help menu. You know, those sort of things allow you to expand over time. And in fact, as we look, we could probably expand, oh, I put my slides in the wrong order. Well, going back to this, like because I'm doing this with the sizer flags, I no longer need that as an argument. Wow, that turned out interesting. As I was saying, I could probably have many with functions, and like just keep adding them with flags. I guess it's so great, I added it twice. Whoops, should read with position, with size, with all the different colors, to the point maybe there could even be with configuration pack, which could allow it being very simple where you call a function which returns a configuration pack because you're like, maybe I'm like, I want all of these UIs that are created with this mode now to have this, and you could at runtime determine that. Okay. So let's see how flexible our UI is about adding additional elements. I've only concentrated on 3 sort of controllers. Let's go back to our original example, and let's say I added in a slider. Ooh, now it's interesting. So slider, I can, like move it back and forth. These are other types of controllers. So how would I add that? Oh, just easy. I would just add another using declaration, and I would add slider. Unfortunately, no. You can't do that. Specifically, it's hard to read there. It's right in the center about how that new W doesn't work. And well, we've sort of been lucky. The controllers that we've been working with so far have been, I would call them isomorphic. They all sort of have the same shape. It's a little hard to see, but all of these, they have a window, an ID, and a string. Those are their first 3 arguments. They have different arguments later on, but we just sort of got lucky. Or it was a rather concocted example. But if you take a look at slider actually supports a different set. And that makes sense because sliders don't have names. They have numbers. They're very distinct, but they are still controllers. And in fact, if you look at the larger hierarchy of controllers that wxWidgets has, it has a whole lot of them that it supports. Just because like there are so many different UI elements we are used to. And so if we think about this, if we were trying to make a very flexible solution, now we're in a bit of a problem. Like how do I create something that can support all of these? And I might not even want to write all of them. I might only want to write a few of them. I might want to make it easy to customize this over time so more people could add their own. So let's take a look at the create and add function that we had for our widget. So we'll see create and add takes in what it wants to create. It's been told by a template argument, create a WX button, create a WX text controller, create a slider. And then what happens is later on, it controls how to create it or when to create it. And there's a design pattern that we use to help separate the what to do from the when to do it or the how to do it. Anybody know what that's called? The template method problem. This is the one I'm like, yeah, not to be confused with templates. The template method is, so in this paradigm, this design pattern, this gang of 4 design pattern, the template method is in the superclass. So your base class defines the template method, and then it defines the skeleton of the operation. It sort of implements it in terms of a number of high-level steps, and then those high-level steps are overloaded by the subclasses. So they effectively create them. All right, so we can restructure that right here. So instead of calling new, let's have, so create now will be our template method, and we want to have a helper method. We'll call it create. And so what we have here is with our create and add function, we will write that in terms of create. So, and we'll note here actually as a side effect of this, we don't need that W template parameter anymore, so we can get rid of it. So now our derived classes have the responsibility of creating the controller. So we'll create now struct class. It will contain within it all of the things it needs for constructing. I actually just pass those on to the base class. And it will implement the helper function. So it will be very explicit about what to do. When you want to create something, this class will create a static text controller. And as we can see here, the how to add and the what to create. Yes?
I appreciate it's essential, but technically there is no reason why that's virtual. You could have done templates still.
I could have done templates. I could have done some sort of like type erasure things. I could have done many other things. I just reached for inheritance.
All right.
Yeah. And in fact, actually, I've been thinking about like, I don't know, what's the problem with virtual functions? You know, like, is it so bad? I think this is, it's where on my journey, it's where I learned, and I was like, oh, I can just do it this way. Quickly did it just to see the pattern that emerges. I think there are opportunities to improve this or change this, or so it's something I'd like to explore. All right. Now there is something that happened from this. Once I added the code, I get a massive number of compiler. It doesn't build. And let me highlight specifically why this doesn't build. Any thoughts as to what happened?
Destructed.
So it's not here. I mean, I can't keep all the code on the page. Let me, we just added the builder pattern. And what happens is, it says here that the widgets, these builder patterns return widgets. But I've explicitly said that widget is an abstract class. So now the compiler's like, no, you can't do that. Widget, you can't refer to a widget because the widgets don't exist. They're abstract. They can't be in the code. So the builder pattern falls apart. What I really would like it to have is that when this was a text controller, to have the builder patterns return text controller references. And when it's a button, I'd like it to have it return button references. All right.
CRTP.
CRTP, right. So there we go. So why don't we just add that as a type parameter? So when I'm trying to do something that varies on the types, you reach for templates. So now take in a template parameter of what the type is to be returned, static cast, and return that type. CRTP. Yes, Dan.
Now for sure you don't need a virtual.
Now for sure I don't need a virtual. I need something how it can know that it can implement it. It doesn't need to be It doesn't need to be virtual anymore. You're right. But then I couldn't have gotten to this place where I could show CRTP.
No, this is perfectly what is CRTP.
Yeah. So. Okay, so we're improving that concept of our data structure. We're creating a hierarchy of controllers. I have my widget-based class, and I've got my text. But now, like, we have this opportunity where, why am I putting details that each of the subclasses need in my base class? Let's move those out and to, oh, come on, what happened to my beautiful animations? Okay. Oh. And so I can see that now details that belong in the base class can be in the base class only. Those are sort of these universal parameters that affect all wxWidget controllers, and I can have the specializations be done in my base classes, or my subclasses. Cool. So popping the stack, what were we trying to do? Right, we were trying to add sliders. Awesome. So let's add, we'll create a slider struct, and now we actually have to think about here, what would our arguments be? And I think this is now an interesting part where it's like, we actually have an opportunity to make things better. Specifically, if you look at the wxWidgets slider interface, its arguments are parent ID, and then it takes in 3 numbers, which are the size, which, let me, I always have to, is it min-max or a value, or is it value min-max? I'm like, I don't remember. This seems a little fragile and dangerous here, where like, really like, no disrespect for the people who develop library, but this seems like an opportunity to just make a mistake. In fact, with 3 arguments there in a row, actually, in fact, it's worse than that. Window ID is an int, so the compiler can't help you if you've gotten that. So it's actually four arguments that are incorrect. And so this feels like not just an opportunity for us to create flexibility with our hierarchy, but to create some safety, to create things, to make things easier to use and harder to misuse. So what would be a good set of arguments to use here? And what I would say is, why don't we have it be that our sliders have to take pairs, which are going to be the min and max. And if you didn't supply one, I will just use the min. And that will be our convention for our library. Want to be able to take an ID possibly. So that would be our constructor set and overload set. And this is what you would end up as your slider implementation. Something that looks like this. It will hold on to its values it needs. When create gets called, it will stamp out a wx slider. So then we just add that to our code here. There we go. Right. So our UI doesn't really do much. Like if you were to click on buttons in this sort of framework, it doesn't do anything. And so let's go back to the very top. At the beginning, we were talking about how you can add functionality to controllers in wxWidgets. It's by calling bind on them. How would we add that to our solution? Well, why don't we hold on to those lambdas as member values in our data structure? So let's just support this with functions. I'm going to use standard functions because I don't want to deal with the type erasure. I'll let it deal with type erasure. And we'll have a map of them. So there's a tag that gets emitted when you click on a controller and a function that gets called. So I need to know the tag type. Some controllers can support multiple tag types. Like in wxWidgets, if you have a text box and you type in a key, it gives you, hey, there's a key pressed event. If you type enter, there was an enter button event. And so it allows you to have multiple ones of those. So why don't we create a helper function whose job is just to simply take all of the map of handlers it has and adds it to the widget, any sort of wx window widget that's been created in. And we'll just refactor our add function so that instead of calling create, it'll call create, hand that result to the bind handlers, take whatever was returned, and just add that to the sizer. We will need some way to populate bound handlers. It doesn't seem like it's the responsibility of the widget. It's probably the responsibility of the subclasses because they know the specific events they're going to generate. So why don't we create a protected member function that we only allow our subclasses to call. So subclasses would use the builder pattern. They would have a bind. It would take in the lambda, and they would then just call the superclass to say, hey, add this to the bound handlers. And then when everything gets created, it would then attach it to the appropriate controller. And so that would look pretty straightforward. So I can add this functionality so that now when that button gets clicked, so you can see like a little animation here. So if I were to click the button, I get a little controller. So I get my dialog box, cool. And then when I slide around the slider, it updates the status field. Pretty cute. Well, so this bothers me just a little bit here, which is why do I need to take in a function argument? Why do I need to force the user to give me a lambda that has a function argument? And so if I look here, I've got my handler, which was saying, I want this. Well, let's make it a variant. Let's let it allow it to take multiple different types. And so I have the type which requires a command event and a type that requires nothing. And now I just need to use the visit pattern to overload it. Yes?
like you could do that when you create a function, probably. Then you don't need a variant.
I don't need a variant when I create it. That might be true, except on the case if I wanted to associate several handlers with the same controller, and they can all be of different types.
No, I don't think it's a problem. So. Like when you create a function from a lambda, you just inspect, and if you need to, you wrap it in another lambda.
Right, right. I could do it at the part where I created it and to have it be uniform. Yes, I'm doing it at the part where I'm calling it. Well, actually, I am kind of doing that right here, which is when I associate it, I make them all look homogeneous to the controller point of view. But is there a way for me to get rid of the variant? There probably is a way for me to get rid of the variant.
Yeah, what he's suggesting is just you can wrap it. You can see if your lambda doesn't use the argument, you can wrap it. So
Yeah.
you can still have the state function which accepts the argument, but just wrap it.
Yeah, I'm wrapping it when I'm adding it to the controller. I could have wrapped it at the place where I grabbed it. But then, yeah, I'd have to, my bind function would, in my base classes would all have to do that wrapping. Like, or would they? No, I think you're right. I think I could probably figure out a way to do it. I'm going to try that out. The nice thing, though, about this was I didn't have to change any of the other subclasses. By adding the variant and the visit pattern here, nothing else about the code had to change. And I can just modify my function and only make it much more clear. All right. So this is where we ended up. And truth be told, I mean, it's only a couple hundred lines of code. A lot of it is rather redundant. Much of it had to do with sort of the builder pattern code that I didn't necessarily need to add, but for completeness, I did it there. I had a couple of subclasses. And if you look at where we came from, I mean, I think it's pretty striking. Combining the controllers and the layout made it easier to see what the intent was. It's really, I think, much more clear to see what's happening on that side, further side. It is impossible to forget to add a controller to the layout because controllers are now part of that declaration. If it's not there in the declaration, it's not going to be laid out. So they're sort of tied together now. Adding things to the incorrect sizer is greatly reduced. Like if it was showing up in the wrong place, it's because it's showing up in the wrong place in the data structure. And it's very dry. Like there's not a lot of repetition on what we're doing. And so I'm gonna, to recap, what I would do is I want to impress that there are data structures in your code. You may not see them. And that might be because you need to do a bit of refactoring. But if you start refactoring, you can find those. Start refactoring your code, try to reduce the number of statements, put them together, and you'll start seeing that, hey, there's actually a data structure here. Can I move that to somewhere else?
Sorry, you say data structures, you don't mean like algorithms and data structures.
I don't mean like a map or anything like that. I mean your own sort of data structures, implicit data structures.
The structure of my data.
Yes.
The structure of a window, as you showed it here, right?
Oh, no, I mean data structures as in like a way of collecting together records, like making a struct.
Ah, okay.
Yeah. Sort of. There's like in your code, there is implicit data structures, like all of, oh, this is a, like, I'm doing the same thing on a collection of objects. Oh, this is a tuple. That's a data structure. And it might not be obvious that's what's happening until you start refactoring your code. Try to make those, like, so I think of it like try to make those data structures more apparent that you can run algorithms on, because data structures plus algorithms is declarative programming. The builder pattern, reach for well-defined patterns to leverage. So builder patterns allow us to make composable elements. I can now do things like have a function that returns a text controller and have a function that adds sort of embellishments on top of it, so that I can sort of add things along and bring they struct along, and I can put it in my UIs. Template patterns allow you to add flexibility and customizations. I did it with inheritance. There's probably other ways to do it, but the idea being is defer the what to do from the when to do it, and it makes it more flexible. If you want to see more of this, I actually created a project on GitHub called wxWidgets, wxUI, inspired from some other languages out there and paradigms. And that's where I've collected a lot of these ideas. And thank you.
I feel like a spoil sport for asking this,
Please, destroy me.
but the Qt way of doing this is create a GUI, place things inside. They don't call it sizes; they call it forgot the name.
Layouts, yeah.
Layouts. It produces an XML.
Yep.
A tool does code generation, turns that into CPP, which you don't have to touch.
Yep.
And that's, I think, even more declarative.
Yes. Yeah, no, in fact, actually, like, there's a lot of tools that do that off to the side. I was looking for a way to incorporate it into the code to see it directly in the code. So that's one of the things that I'll be honest, inspired by something like Swift UI, which does this sort of same paradigm, which is to embed the layout inside the code so that you don't have a second step. And I was curious to see if it could be done, and this is what I ended up with. So yeah.
Can I just
And the rebuttal.
can you show the code last? Yes, this one. Qt actually went further and they created their own language called QML, which looks exactly like that. A little bit different, but the same.
Yeah, they have a little. Is it directly in C++, or in the code? It's off.
They went two directions. So
Quick.
QML. It's called the
QML.
QML language. Now they actually do. It's a pure standalone language. Now they actually do take it and generate out of it C++.
Yeah. So
Actually, they do even more. They also annotate. So
yeah, and wxWidgets has an XML generator and also does the same thing. They do have an XML. They have a separate tool for doing your layout. So yeah, I think a lot of these paradigms do that. You end up going in a direction of making a essentially a data structure off to the side with another tool.
because it's easier to be fully declarative this way.
It's much easier to be. Yep.
Can you also show the two codes side by side? And you asked the question: is the one is more powerful than another one? I'm not familiar with wxWidget that well, but in big UIs, usually, for example, if you have a slider, right, and it goes to 0, you want to disable some button.
Yes.
How did you solve the bindings in this scenario? Because I played with that pattern myself, and it was.
Yeah, that was one of these. I probably have another like 40 minutes.
We can take it after.
But so my larger UI does look at a way to solve that. Well, effectively, how you're in this sort of situation where you're like, I need to get one of these controllers to another controller's like function handler. And so like, I'm like, okay, well, these don't exist in the data structure. I need to have a way to telegraph to essentially, I call it the engine, the fit to function is one that sort of starts laying things out. And in there, I need to say, hey, when you encounter this class, I need to get a handle back to this one. And there are ways to do it. And I think I came up with a pretty interesting way to do it. Maybe.
I'm perfectly fine to look at it after.
Yeah.
Very interesting.
But the Qt solution to that question, by the way, is to have a layout that already includes the slider. And therefore, it's out of your hands. You just tell it how big the virtual desktop is. And it auto-calculates whether the slider needs to be shown and how big it is.
No, it was more like when you need like my slider goes to 0, right? And then when it's 0, I want to disable OK button, for example.
You want to disable an actual other controller.
That's more bindings.
That's not different than having a button that, if you press, brings up a dialog. It's a
No. It is very different because I'm not just bringing up that dialog. I need to go back to the original UI layout and have it explicitly affect one of those other controllers. You need the controller. How do you have the layout? How do you have these controllers reference other controllers in the layout without that data structure existing?
But
in Qt, they actually do in QML, every element has an ID which you can refer.
But the WX way is by ID.
Yes, you can do it by ID, which is to say, hey, I've got these IDs, and that would be the way. I would declare a specific UI ID, and I would then have it be passed in as a function. But then now I've got my IDs I had to declare somewhere else. The question will be is there a way to do that without having an external place to look for the IDs? Could it all be self-referential? Okay, Dennis.
I'm just curious. So this style of UIs, the original one at least, is the whole. This is a poster child for object-oriented programming that is impossible to optimize. Right? You have all these small functions, trees that go everywhere. Do you have any thoughts? Because I don't know how to solve that. Do you have other than JavaScript and we compile the HTML instead? Is there something we can do?
Wait, say that again. Like the fact that it's the whole framework is object
The whole
oriented.
framework is built around really tiny functions that call other tiny functions. Everything is virtual. Everything is absolutely unoptimizable, and your computer likes to do loops that do the same thing. This is the opposite of that.
Yeah, I'll say I deliberately did not attempt to go below wxWidgets to fix wxWidgets. I'm just really using the framework. I actually find with UIs and those sort of paradigms, I'm not really worried. If performance is a concern, I'm never really worried about performance with a UI so much. It's really because the UI is really just there so I can interact with the underlying algorithms. And so I found that I haven't really focused so much on how to optimize it. In terms of composability and the way things interact with each other, I think UIs and the way things interact are complicated. Applications at a large level with the interaction with a human is complicated. And I don't know if I could say that complexity is necessary, but you are able to build powerful applications on top of it still. Right. You had a question?
I'm not sure actually if it's a different question from the previous discussion about connecting the various elements, but we have slider here. How do we get the value of what it's currently pointing to?
Yeah. How would you figure out in your larger program what that slider is?
Yeah.
And that's so if I needed to reference the controller outside of it, that's where that ID usually comes in. So what you would do is if I have some other part of the code that needs to reference something, you can, my other function can say, hey, large window, what is elements, ID flag mean? And it'll say, oh, that's what that is. So can you get around that? But yes, so I have a way of creating sort of these proxy objects in the larger ID, which allow you, as this is created, you're like, hey, here's a handle to that thing, and you can now extract values from it. So that's the way it's all. Or you could also go with the ID approach. Sorry. Cool.
You talked about my words, the semantic complexity of a GUI application that needs to be modeled. Actually, again, the Qt solution there seems very, it seems like a good abstraction where it says UI elements create events and you create handlers. The connection is part of the semantic thing you can do with a GUI, with a wxWidgets setup you do. And that really separates out the semantic processing from the UI.
Right. But the thing about it is the element that you want to present to the user, it will generate events, but that element could be different depending on what sort of interaction you want to have. So at a fundamental level, they should emit, GUI elements should emit events to inform the program about what happened. But they might want to inform the user about a text event or a value event or a value, a number sort of thing. And using one type of controller for that isn't appropriate. You might want to have different types of controllers, and you would derive, that's where deriving them to say, I'm going to specialize this way to show the user this information.
Qt has different event types.
Okay. No, it's not the event type, it's the way to present to the user what it looks like. I'm saying, I agree that the event types that it emits.
You lost me, I'm sorry.
I think where I was trying to get to was, why does something like object-oriented programming favor UIs is more along the lines of, because you want to have specializations. You want it to do the same sort of thing, but you want it to look differently. I think that was my point. So,
what's the testing story here?
Oh, actually, it's an interesting one. I found this is really interesting because for me, what it was is I was I can go through and just check the data structure. So I can say, hey, I've created a data structure that has these, and then I just check to see the members are consistent. How do I know, and then how do I test it to make sure it creates the right thing? that would be after, so you would have it construct it, and then I would take a look and introspect the elements of the frame that was created. So I found it actually easier to test because I was like, I moved my testing to what does this, like make sure that I had sanity on what got created, and then called the fit to with the various items to make sure it constructed my elements correctly.
A lot of UI elements, as long as when you go to some real applications, have pretty complicated logic. Like if you have in a browser, you press a backspace, then you press space, it will suggest you certain things. It will appear, like some visual elements will appear, right? So those kind of things, they're really tricky to test. So I'm wondering if you have thoughts on that.
Oh, that I don't know. Yeah, I didn't test that. I was mostly checking out the composability. So you're talking about like if a UI has to be redrawn. Sort of in that case, I would assume with this model, what you would do is you just give it another data structure, you create it and have it fit. So you're not really, you're testing the ability for when I push a button to have it construct another layout. Well, I've tested constructing the layout, and now I'm just testing that. I don't know that. It's not a very satisfying answer, but
I think the way to do it is to construct both layouts and then hide one.
that would be a way to do it too.
And then it's just a flag. But it's been years since I worked with the wxWidgets.
So,
Have you tried it on a lot more complicated GUIs?
can I try it on a lot more complicated?
Have you tried it?
Yeah, like here's a backup slide. Yeah, so this is like the original one that we had at the very beginning, and that's what it would look like in the sort of an earlier version of this example. That's why I skipped it. But yeah, I've tried it with a lot more complicated code. In fact, actually, I think I've at this point the CalChart project. It's written mostly in this in every part I could. I think except for some of the menu system. I haven't gotten all the menuing quite right. But yeah, no, I basically replaced everything inside the larger application I use with this.
Just an observation, you can't create good infrastructure if you're not the infrastructure's user. That's what I'm getting from because this was 100% driven by your need to do this simpler.
Yes, actually, and I would say a version of this talk I did was talking about being a library writer, and it's because effectively I became a library writer for this, but I had to have so much domain knowledge. You can't write a library about an area you don't really know a lot and you're not dealing with. And so I was dealing a lot with this. And in fact, actually, like after writing this, I was like, oh my goodness, I can do things like I had like a controller that had a bunch of buttons, and I'm like, oh, there's a for loop here. It's like, great, now I have a for loop data structure. And it was one of these things I would have not come across that unless I had my own code base I was dealing with. And so, yeah, you're right. So it does, I think it scales. I think it can be used in other places. I benefit from the fact that I only was using it for myself.
Since we mentioned Qt many times here, I'm just looking by your code on the right side. So it actually doesn't have anything related to wxWidgets except some variables, right?
Yeah.
Have you thought about support different backends?
Oh,
like Qt or wxWidgets or something else? I know it's your pet project in a way, but still. Because it's kind of opened the door, right?
It does sort of open the door of like, could you do this in Qt also? And would it look the same? Because really...
It will exactly look in the same, actually.
And maybe to the point which... I mean, a little bit of the lesson there is saying is like, I've created a data structure and that sort of fit to function. It's like, I've thought of this as like, hey, there's a data structure and there's an engine. There's like my thing that like, I put everything together and then I just throw it to this engine and it implements it. And in that regard, well, that thing that's implementing it, it could be configured for Qt. It could be configured for a different UI framework. It could be configured for, I've often thought like, maybe there's a way to write
I think a better way to say is that this is becoming a UI framework.
Oh, I don't want to go that far.
I think, but if you follow his advice, that's exactly where you'll find it.
I was not suggesting that. I was more thinking like we have a data structure, as you say.
Yep.
Radio box is a data structure, and whoever draws it, renders it, and put it in a frame, it's an engine, as you said.
It is.
I'm not suggesting to go that far, but I'm just saying it's an interesting touch.
Just like wx itself on Linux translates to GTK,
Yeah.
right? And GTK translates to X windows.
Yep.
If you follow down that, right, that's exactly where you'll find yourself.
I do want to write this on top of curses, and just have it be a complete text interface would be a really interesting thing to do. So, I think that's a great place to end. I want to thank you guys for all the questions. Thank you for listening.